When discussing blockchain technology, the term distributed network often comes up. But many people still have a difficult time explaining what a distributed network is, whether there is a difference between decentralized and distributed networks, and what benefits these network structures have over centralized networks. Each different type of network architecture comes with its own set of pros and cons, which we will discuss in this video. Hello everyone, and welcome back to the Metaverse Economy channel. In this video, we are going to discuss distributed networks and other systems in blockchain technology. I'll be providing answers to questions like, what is a distributed network? Is it different from a decentralized network? And what advantages do these network designs have over centralized networks? Don't forget to subscribe if you want to catch more videos like this. Let's start with the main topic of this video. What is a distributed network? A distributed network is similar to a decentralized network in the sense that it forgoes a single centralized master server in favor of multiple network owners. However, distributed networks are composed of equal interconnected nodes, meaning that data ownership and computational resources are shared evenly across the entire network. The term distributed network is sometimes used to describe a network that is simply geographically distributed but may follow a top-down node hierarchy model. In most instances, though, the term refers to a network where node locations and computational resources are evenly distributed. Because distributed networks do not have a central server or a separate set of master nodes, the burden of data processing is crowdsourced across the network, with all users granted equal access to data. The decision-making process on the distributed network therefore typically involves individual nodes voting to change to a new state, and the final behavior of the system changes in accordance with the aggregate results of the decisions each individual node votes on. The specific processes by which a distributed network votes and makes decisions is contingent on the network's consensus mechanism. All forms of distributed decision-making involve the network's individual components interacting with one another in order to achieve a common goal. Due to their geographically scattered nature, distributed networks are consequently extremely fault-tolerant and secure. Their advantages and disadvantages closely mirror those of decentralized networks, but at a higher magnitude. Distributed networks come with several benefits. Firstly, it has extreme fault tolerance. With distributed networks, a node can fail independently without affecting the rest of the system, since the computational workload will simply be rebalanced among the remaining nodes. As a result, distributed data systems are significantly more robust than other network architectures that rely on some form of top-down node hierarchy. Another benefit of distributed networks is speed and scalability. Distributed networks are more scalable than both centralized and decentralized networks. They generally exhibit lower latency as well as even distribution of network processing power and data. There is also enhanced transparency with distributed networks. Since data within a distributed network is shared evenly across the entire network, it is significantly harder to successfully modify, censor, or destroy information on the network. As a result, distributed networks are intrinsically more transparent than the other systems, particularly given the fact that they often utilize cryptography to secure their data. While there are some great advantages of using distributed networks, they're not without weaknesses. The most significant is the high maintenance costs. As is the case with decentralized networks, distributed networks require more resources to maintain or reconfigure, since any meaningful change requires updating every individual node. And since the distributed nodes have different latencies and do not follow a common clock, network administrators cannot temporarily order commands or logs. As a result, it can be difficult to design and debug algorithms for a distributed network. Just as worse in the coordination issues that come with the distributed network, in the absence of a node hierarchy, there are no superior nodes overseeing the behavior of subordinate nodes. And consequently, there is no way to regulate individual nodes on the system. It can therefore be difficult to make timely decisions or achieve large-scale tasks. This decentralized chain of command can be an insurmountable issue for certain businesses and organizations. Furthermore, since it is difficult for any individual node to gain a global view of the entire network, it is therefore harder for individual nodes to make well-informed decisions based on the state of other nodes in the system. Now that you know what a distributed network is, let's see how a decentralized network compares. By contrast, a decentralized network distributes information processing workloads across multiple devices instead of relying on a single central server. Each of these separate devices serves as a mini central unit that interacts independently with other nodes. As a result, even if one of the master nodes crashes or is compromised, the other servers can continue providing data access to users, and the overall network will continue to operate with limited or zero disruption. Decentralized networks are made possible by recent technological advancements that have equipped computers and other devices with a significant amount of processing power and can be synced up and leveraged for distributed processing. However, while decentralized networks are substantially different from centralized networks, it's important to note that decentralized networks do not distribute data storage and processing evenly across the entire network and still rely on main servers, albeit more than one per network. As usual, there are several benefits when it comes to a decentralized network. Firstly, you get increased flexibility, scalability. Since decentralized networks do not have a single point of failure, they can continue to operate even if a master node is compromised or shut down. Furthermore, decentralized networks are easy to scale since you can simply add more devices to the network in order to increase its computing power. And network maintenance typically does not necessitate a full network shutdown. There is also a faster performance. User requests are often completed faster when using a decentralized network because network administrators can create master nodes in regions where user activity is high, as opposed to routing connections over vast expanses to a single centralized server. Lastly, you have enhanced privacy. Decentralized networks enable a great degree of user privacy. Since information saved on the network is disseminated across multiple points instead of passing through a single point, this makes data flow more difficult to track across the network and eliminates the risk of having a single target malicious actors can go after. Just as with distributed networks, there are some demerits to using a decentralized network in a blockchain system. A significant problem is the high maintenance costs. Decentralized networks are more fault-tolerant than centralized networks. This makes maintaining these networks typically more costly and labor-intensive. Since a decentralized network relies on multiple devices to underpin the system, this places a commensurate burden on the organization's IT resources. As a result, decentralized systems are often not suitable for organizations that only require a small system, since the cost-benefit ratio isn't favorable under these circumstances. Another problem is coordination issues. Since master nodes within a decentralized network act independently and may not communicate with one another, larger organizations may run into coordination issues and have a difficult time directing and achieving collective tasks. While this is a deliberate feature of decentralized networks, it means that not all business models and organizational structures will necessarily benefit from using a decentralized network. While they do have their differences, a distributed network might also be said to be decentralized. In these situations, every computer on the network can be used for any task requested by any other node, leveraging unused computing power from idling machines. Decentralized distributed networking is the basis for blockchain technology. Decentralized distributed networking allows for the operation of blockchains, which rely on the distribution of data and the mutualization of computing power. This form of networking also provides major benefits for those seeking anonymity, which is an important cornerstone of cryptocurrency and blockchain projects. That is on distributed networks and how they compare to decentralized networks and blockchain. Hopefully this expose was helpful and gave you some insight into how these systems work and which will bring the best results. Thanks for watching, and if you found this video useful, please hit the like button and don't forget to subscribe.